Okay, so far what do we know about linear systems? We know we can solve them by graphing and looking for that point of intersection, if there is one. And that would be the solution to the linear system. That's always the solution to the linear system. You know, the x and the y that make both of them true, where the two lines, if you graph them, where they intersect. So one way to do that is to graph. Another way is substitution. You need an x equal or a y equal. You plug that into the other equation. Solve like crazy for one of the variables, plug that in for the other. And the elimination method, which is what we looked at last time, we looked at kind of a simple version of it. Excuse me, where you can just add them, one drops away, and it's a little bit easier, I think, than substitution, right? So we decided to do this. We're not really going to subtract because why not? That's right. I think subtraction can be confusing and error prone. So in the case where you have like an x and an x, and you want to subtract, multiply one of the equations through by -1 and add. It's the same thing as subtracting. We also, pesky fractions are kind of a pain. You can multiply through by the denominator. You may have to do it more than once if you have different denominators in there, or you can look for at least common multiple of the denominators. So we can get rid of fractions to make our lives easier. So now what? Sometimes we can't just add or subtract. It's not so easy, and you guys saw this last time. So for example, if I have this linear system, 5x plus 2y equals 16, 3x minus 4y equals 20. So the idea is you say, gee, do I have any opposites? I don't. Do I have any sames even? No. And this is far more typical, right? They don't always work out so nice. So what do we do? First, we're going to find the least common multiple of the coefficients of one of the variables. What? So let's look over here. What's the least common multiple? What's the least common multiple of 5 and 3? Yeah? Okay, oh, you're thinking of the greatest common factor, I think. Right, we had those two things. Well, think of multiples of 5, right? 5, 10, 15, right?
It's the smallest one that both.
And then, right. So 3, it's 3, 6, 9, 12, 15, 18. What's the least common multiple? The 15. There are various ways of finding it, whatever. But it's the same thing. Let's say you wanted to add fractions. You know how fractions have to have the same denominator?
Yeah.
So what denominator would you make? 15. So it's the same process. So you look at the 5 and the 3 and say, oh, 15. Because remember, I want them to be opposite. So first let's see if I can get them to be the same. So what would I multiply 5 by to get it to be 15? And what would I multiply 3 by? Right. So then if I multiply, I have sames. Now I want better than sames, right? I want it to be opposite. So how could I make them the opposite? Make one of them negative. Now what would get multiplied by 3? And what would get multiplied by -5? Everything. So we multiply through. Because this is, I should really write it this way. Because we're multiplying both sides of the equation by 3. Multiplication property of equality. So I would get 15x plus 6y equals 48, right? And what happens on the bottom? Okay, carefully. Negative 15x, negative times negative, that's a positive, equals negative 100. Now, if they're equivalent, and I should really write it this way, because that is actually what I'm doing. I'm multiplying both sides by the same thing, because they'll still be equal. So this is equivalent to that. Now, I had another choice. That was if I make the x's be opposite. What else could I have done? Make the y's be opposite. So I look at the y's here. Least common multiple. 4. Well, okay, so how do I get the 2 to be a 4? By 2, and will they be opposites? Yeah. So what would get multiplied by 2? Just this guy? No. Everything. So what will we have here? 10x plus 4y equals, now do I have to multiply this guy? No. So which one was easier? The second one. So basically the process is, well, which one do you do? You look at both. What do I have to do? Multiply that by 3, that by -5. What do I do here? I just have to multiply that by 2. That sounds here? I guess I'll do that. Would it be wrong to go here? No. Then let's show why not. We're going to add to eliminate, because now I have my opposite. So get rid of that. Gone, right? So what do I have here? 26y? Negative 52? Divide both sides by 26, right? So what's y? Negative 2. And I would plug back into this equation. I would go up here, either one. 3x plus 8 equals 20. So 3x equals, I'll say 18. X equals 6. Hopefully I did that right. How would I know? I'd plug them in to make sure. Now what happens if I do this one? Did I do it wrong?
Yeah.
What did I do?
Subtract 8.
I subtracted 8. Oh, it should be 12.
Yeah.
Thank you. So that's a 4. Well, good thing I should have checked it, right? Now let's try this one. 13x. That goes away. 52. So what's x? 4? I'm dividing by 13?
Oh, sure.
Isn't it? I don't know. Am I wrong? I could be.
No, you're right.
I'm right. Well, I know that because there's 2 cards in the deck and there's 13 in a suit and there's 4 suits in a deck. You know what a deck of cards is? Anybody? Anybody ever play cards? Yeah. 52 cards, 4 suits with 13. Yeah, I got that right. That's good. And then you go back, plug it in. Okay, we'll do it. 3 times 4 minus 4y equals 20. 12 minus 4y equals 20. Subtract 12, hopefully correctly. Y equals negative 2. Oh, so you get the same answer. So it doesn't matter who gets to be, the least common multiple, who you're going to eliminate. So everything's the same once you go ahead and get it to the opposite. Multiply through. Sometimes you have to multiply both, like when we did the 3 and the negative 5. Sometimes you only have to do one of them, and if you're lucky, maybe you don't have to do it at all. That's if you're lucky. What are the steps? Multiply through one or both equations by a constant so that a variable will drop out if equations are added or subtracted, right? You want to make opposite. Once you've done that, what we did last time, follow those steps. Add or subtract equations, solve for the one variable, plug back in to get the other, and check your results. Least common multiple is how you'll know how to drop one out. Here's one. Oh, look at that one. What's the problem? I need to rearrange, make it the same form. Which way should we go? Should we make it look standard or do we want to make it look like that? Standard. Yeah, we're partial to that. So that means that this x variable's got to go to that side. And so remember, I'm just copying the first one here. Moving a term to the other side, it just changes sign. So if it was positive on this side of the equal, it's going to be negative on the other side. All right, great. Uh-oh. Yeah, there, I don't see any opposites. So what are my choices? Well, least common multiple, 12, right? So I can multiply this one by 3 and this one by 4. Or, look at 10, so I can multiply that by 2 and this one by 5, or, remember, I want opposite. Yeah, so I want opposite. So since these are the same sign, one of them should be negative. Well, which one?
That one.
Do you want to do the second one? Okay. All right, so everything, right? Everything gets multiplied by these numbers. 8x plus 10y, I want to say 70. All right, now I'm multiplying by negative 5 here. 15x, so negative times a negative, minus 10y equals positive 45. Okay. What are we going to do here? Add the equation. 3x, that goes away. Oh, I hope somebody has a calculator, I hope. Because, what is, right, divided by 23? What's, 115 divided by 23? 5. Is that 5? Alright, so halfway there. That's the x. Pick one of these. I'm going to pick this guy. 2y equals 3 times x minus 9. 2y equals 15 minus 9. 2y equals 6. So what's y? 3. And then we have to plug in both just to make sure I haven't made a mistake. Let me just see what the next thing is here. Yeah, ooh, the word problem. So when you come back, see, attack it first before we discuss it. So have a good one.
So I wrote out here, you know how many tickets you sold in total, but you don't know how much each ticket costs.
Right.
So you have to do multiplication of each ticket cost, and you don't know what ticket is.
Right. So let's go back to that. You don't know what they cost. So notice the let statement. Let X equal what the senior citizen talking about. She used X. That's fine. You can use whatever you want. Y is the youth ticket. How much it costs. She used a C for child ticket. Okay. So you can use any variable you want. Using S and C will help you remember what they are. So it's a good idea to use letters that maybe are something that's like what you're working with. So that's the first thing. What am I trying to find? And then you use what you know. The first day, 3 senior citizen tickets. So 3 times what those tickets cost, plus 9 times what the child ticket costs, equals $75. That's the information from the first day. Then you look at the second day. Now they mixed up the words a little bit. You read the whole sentence. They made $67 that day. How did they make $67? 8 of these senior citizen tickets and 5 of these child or youth tickets. So 8 times the price of a senior citizen, I'll use yours, plus 5 times the price of a child was the 67. Well, let's just see if there's questions at this point.
Oh, I know it is.
Well, but look, the answer is nice. But how do we get there? So I want to make sure we understand how to get there. So then what should we do, Victoria?
So since we don't have the like term, I look for the one or as I said, what would be easier for me is to multiply 1 and 9 and 5.
Okay, so let me just slow it down. She wishes so good she got it. So she said, okay, I need to eliminate one of these. And she said, well, let me do this one. So 3 and 8, right? They're not opposite. Oh, you did 9 and 5. Okay. So she said I could do this one or this one. 9 and 5. Okay. That's fine. You could do either one. She said, I'm gonna make these be opposite.
Yes.
How do you make them opposite?
I multiply, since you have to find your LCM. So
Okay,
I
you
know
come and
that
multiple.
9 is 5, 5 is 9, but I wanted to make sure so that they're opposite, so for the bottom and the middle.
Okay, so you said 45. That's what I want them to be. One to be a plus 45 and one to be a minus 45. So if I want the top to be a plus 45, I would multiply it by 5. But what gets multiplied by 5? Everything. Now to get the bottom to be negative 45, because I want them opposite, what do you multiply 5 by? Negative 9, but you just multiply the 5? No. Everything. So then we rewrite these, right? So what do we have here? 15s plus 45c equals, help me here, 75 times 5.
There's going to be what?
Why did I think it was 600? I'm going to go
Oh, no.
Okay, and then negative 72s minus 45c. Negative something. It was 600. It was there somewhere. Okay, so I have my opposites. Fantastic. I can add. What's 15 minus 72? Negative 57s. These are gone. Equals, what's 375 minus 600? Type in.
Negative 2.5.
225? All right, and then I divide by negative 57 to see the price of the senior ticket, right? Because that's what that stands for, the senior ticket. So what's negative 225 divided by negative 57? Is that right? Something doesn't sound right here.
Yeah, it is. Negative. Wait a minute. I was actually for the first one. Yes, 3.94.
What? I didn't think this was a rounding question, but. I don't know, I'm wondering what's going on here. Yeah, gotcha. Okay. Something doesn't sound right to me, but all right. Did you get something else? Because something doesn't sound right. She went and she solved for this senior ticket. Something's wrong. That's all I can say. Yeah, I do too. So something's wrong and I don't know what's wrong, so we gotta figure it out. No, it's not rounded. It shouldn't have to be rounded. Whatever's going on here, something is very wrong. So I don't know what I did wrong. I gotta find it. 3x, the S's are confusing to me because they look look like 5s. So, well,
Wait, it's 9. Wait, why do you have X, Y, X,
okay, hello, we're very good. Right? She did it with a student ticket, or senior and child. I did X and Y.
Oh, you switched it.
75 times 5. Yeah, it was messing me up, and I don't know if that's, what's the problem? Something bad happened. 375. And then this one, negative 72x minus 45y equals negative 67. Oh, that's not right. Is that right?
We got negative.
Okay. Before we had said 600, that's why they came down that way. Then we do, yeah, but 603, yeah.
What are you gonna
All right, so 15x minus 72x is still going to be negative 57x equals 603.
Oh yeah, I did do that.
Negative 228. That doesn't sound right either, but let's see. Awesome. All right. So x equals 4.
Yes.
Okay. All right. So there we go. 4 is the price of the senior ticket. Now we have to find the child ticket. You pick one of these. You plug in the senior ticket. Well, that's 4. Plus 9y equals 75. 12 plus 9y is 75. Subtract 12. I did. Anybody watching this video? It is Friday, late in the day. All right, so 75 minus 12. Yeah, we're recording. So y equals 7. So the senior ticket is $4 and the youth ticket is 7. You would check it by plugging it in both, making sure they add up to the right numbers. We probably should. If I had more time, I would do it with you because, you know, we're going to have a mess. Whew, I do it a couple of times. All right, so I've got a couple for you to do here. We're going to spend maybe 5 minutes. So do maybe 1 or 2 of them. Just pick like maybe these 2. So what are you going to do? So remember, you look first. Do I have opposites? No.
No.
You look second. Do I have sings?
Yeah.
Second next thing? No.
Or no.
So now,
Understand.
quiet. Be quiet. Be quiet. So you look and say, gee, do I want to make these opposites? Or do I want to make these opposites? And you look what it would take to do either one and then make a decision. You're not wrong. Whichever one you pick, it's not wrong. See if you can pick one that's less work. You'll be less likely to make an error. Yes?
If you have 3 negative 3, does that not count?
3 negative 3. What equals 3 negative 3? Oh,
Oh,
yeah,
added.
right. Remember, our goal is to get rid of a variable. So I'm only looking at the variables. So you go, try it. Give it a try. All right, so did anybody get A? Yeah. You almost got there already. Now here's the thought process. Here's the thought process. Gee, if I want to get rid of these x's, what's my least common multiple? 6, right? So I have to multiply the top by 3 and the bottom by what? Negative 2. Why negative 2? Because I really want opposite. Now I looked at the y's, and I said, gee, okay, what's the least common multiple with 5 and 10? 10. So all I would have to do is multiply the top by what? 2. What kind of 2? Because I want it to be opposite. And then I don't have to change that one. Well, that's easier. Now, if you went ahead and did the x's, no problem. But I went and examined both just so that, maybe there's an easier way. So I'm multiplying the top one by negative 2. And now I can see my opposites. Negative x equals negative 9. So what's x? 9. Yay. Now we're going to find the y by plugging back in. 2 times x plus 5y equals 3. That's the top equation. Subtract 18. What do I get? Negative 15? So y equals negative 3. So that's where these came from. I did plug them back in. We're running out of time here. I can't do that for you. Should you be doing it? Yes. Check them. Noticing on some of these spiral equations turned in, people didn't check. They didn't check your solution. No wonder you're wrong. No wonder.
That was for
Well, good.
Quiz.
I know you did because
On the quiz, I checked it. Yeah.
What kind of 4? If I want them to be opposite. Or you could do these. Doesn't matter. So what's the least common multiple? 6. So I can multiply by 2 and negative 3 because I need them opposite. Either way. It doesn't matter which way you go as long as you're consistent. One's going to knock out. Yes, sir?
You make it -2 and then positive
Yes,
3?
absolutely. You just want opposites when you're done. Yes? Wait, I don't know what this far is. On this one? Okay, you went the other way. You did 6x plus 15y equals, put it right here, 6. And then what's the other one? Negative 6x minus 20y equals 6. Yes? Is that what you have? Then you add. Yeah, since we're gone, 15y minus 20y. Okay, so I've messed up right here. I cannot see this right now. Okay. That's 3, and that's negative 2. 6x plus 15y equals 9. Negative 6x minus 20y equals 6. I'm adding. Negative 5y equals 15. So what's y? Negative 3. We should get the same thing if you even do the other variable. Okay. For now, I'm skipping this only because we're running out of time. You should have had, did everybody see that other piece of paper on their desk? This is other notes. Skipping that. Basically, remember we talked about this. You can have one solution, right? When does that occur? Lines intersect. You can have no solution. That's when you have parallel lines. They don't intersect at all. You can have infinitely many. When does that happen? You grab one line, the other line right on top of it, right? So we're kind of looking at those examples here. We're going to use the graphing method and elimination method on this system. Remember the graphing method? I need y equals, right? So I can graph?
Yeah.
So let's see. The first one, I subtract the 3x to the other side and I divide by 2. That's this equation, the top one. This one, I subtract 3x and I divide by 2. Negative 3 x plus 1. And then I graph. Remember how you graph? N equals negative 3 halves, v equals 5. So I go to 5, down 3, right 2, down 3, right 2. Then I graph this one. This one has a y-intercept of 1. Same slope of down 3, right 2. Well, what's the solution? None. Right. There's no solution. The lines are parallel. They don't intersect. Now, what if I use the elimination method? What would it look like? Well, let's see. Here they are. I need opposites, right? I see some sayings. So I should multiply one of these through by negative 1, right? So I multiplied the bottom one through by negative 1. I'm just going to rewrite that top one. And let's see. Uh-oh, what's happening here? That goes away. That one goes away too. Negative 2, that's 8. Now that's crazy, right? When you lose your variables and you get something wacky like that, what does that mean? So if you are trying to solve an equation, or a linear system rather, and you get wacky, that means you ran into some parallel lines. No solution. So when you eliminate and are left with the false statement, there are no solutions to that. So sometimes wacky things can happen. You have parallel lines. How else do you know they're parallel? Same slope, different y-intercepts. If you happen to notice that, you can also tell that there's going to be no solution, parallel lines. Infinitely many. Here's an example of that. So let's try the graphing method. So to solve this for y, I'm going to subtract x from both sides. I go ahead and do that. Then what do I divide by? It's -2, right? Everything? So y equals, well, negative over negative is a positive. Put in my invisible 1. Half x, negative over negative, positive 2. Yes.
I thought you said that you didn't have to do that.
Oh, now I'm graphing. So when I'm graphing, yeah, I need y equals. The other time, all I was doing was putting two equations in the same format so I could eliminate. So I was doing different things. But yeah, I know it's confusing right now. Up 1, right 2. All right, so here's my first one. Right, the slope was a half, and the y-intercept was 2. Let me go graph this guy. Slope is a half, the y-intercept is 2. Wait a second. Oh, wait, they're the same line. Where do they intersect? Where are we? How many solutions? There's an infinite number. So I can't really give you an answer because it's every point on this line. Now, if you were to use the elimination method, like say, okay, go ahead, solve this. Because sometimes you don't know what it is at first. So I'm seeing that y equals half x plus 2 right away. I'm like, I don't want a half. How can I get rid of that before I even start? Everything. So I get 2y equals x plus 4, right? And now I need to be in the same format. This one's a standard form. I'll do that. Let me move the x to the other side. Okay, so that's the second one. Let me rewrite that guy under it. X minus 2y equals -4. 0, 0, 0. 0 equals 0. That's true. It's weird, but it's true. What does that tell you? When you lose your variables and you get a true statement?
All the numbers.
All real numbers. Well, not all real numbers. It means, well, yes, but there's infinitely many, right? There's infinitely many solutions. I'd rather say that. Because we're looking for the x's and y's that work. So when you eliminate and you're left with a true statement, that's what it says under here. You're left with a true statement. There are infinitely many. Let's see if I can get this to work. There it is. There are infinitely many solutions. So you got to watch for this. You're sitting there, you're solving, you get something weird, there's no variables left. True statement, it's one on top of the other. Infinitely many solutions. False statement, something weird, no solutions, parallel lines. Now you can tell this also by looking at slopes and looking at y-intercepts. So if your slopes are different, right, that's a case where there's going to be an intersection, there's a solution. If your slopes are the same and your y-intercepts are the same, that's the same line. There's infinitely many solutions. If your slopes are the same and the y-intercepts are different, well, that's parallel lines. How many solutions? None. So just by knowing slopes and y-intercepts, you can save time. Or you can say that's more time because I'm figuring out ahead of time. But if you notice that, you may not have to go and solve it. Okay, so, how much time do we have here? Okay, we have a couple minutes. So if I want to know how many solutions, what's the slope of this? Well, let me put it in y equals mx plus b form. What's the slope of the first equation? And what's the y-intercept? Now let's look at this guy. A little more work here. Negative 2y equals positive 10x, excuse me. Right? Look at it, plus 4. Divide by -2. So I'm getting y equals -5x minus 2. Slope is -5. And, y-intercept is -2. What can I conclude about the solution? Infinitely many solutions. Because I have x's and y's, it's not going to be every possible one, but just the ones on the line. Infinitely many solutions. We can do that for this guy too. 2y equals -6x plus 3. Y equals -3x plus 3 halves. -3 halves. Let's do the other one. Just solving for y here. I'm doing a little bit quickly, but you're doing all the dividing and multiplying. -3, -5 halves. Same slope, different y-intercepts. What do I know about these two lines? So there are. Right? So it's just a way to kind of figure it out ahead of time. You don't have to solve it. Or solve it, and you'll see that, you know, things drop out, and you have to remember what they
Well,
were.
we're supposed to grade all that down.
So, here we have, the practice ones. You can work on them for a little bit. While we're doing that, I'm gonna give you out of the homework.